Hi, welcome to 𝗬𝗪𝗧𝗧𝗘𝗡 channel. In today's video, I'll show you how to integrate this Sovol Filament Dryer into Home Assistant using ESPHome. With this upgrade, we'll be able to monitor the dryer's internal temperature and humidity, as well as control it wirelessly right from your phone or computer. So, let's get started. The Sovol Filament Dryer operates using 3 touch-sensitive buttons on the front panel. Unlike mechanical push buttons, these touch buttons detect slight changes in electrical fields and trigger a response when a finger approaches. The ESP32 modules with capacitive touch pins are great for directly detecting these types of inputs. I first tested this setup using the ESP32 30-pin module, where both triggering and sensing worked perfectly. But since I planned to fit the module inside the dryer, I needed a more compact option. I then tried the ESP32S3 Mini. Unfortunately, I couldn't get the touch pins to function correctly with ESPHome. So for this project, I switched to the ESP32C3 Super Mini, which is even smaller and fits better inside the dryer. It doesn't have built-in touch pins, but I'll be using the dryer's onboard touch key IC to handle touch detection instead. To electronically simulate this touch, I'll use an optocoupler to control each button to simulate a finger touch. The optocoupler I'm using here is the 4N35. Each one will need its own resistor to connect to the GPIO pins properly. For the internal temperature and humidity data, the Sovol control board uses an AHT20 sensor, which also provides an I2C output. So I just simply added a 4-pin 𝗬𝗢𝗣𝗢𝗡𝗘𝗡 connector to the board socket and linked it to the ESP32 to track those readings directly in Home Assistant. I'll be setting everything up on a prototype board to keep installation easier. You can find this wiring diagram in my written blog post. The link is in the video description. Initially, I used a 7x3cm board, but I discovered it hardly fit inside the dryer after trying to install it. So I need to switch to an 8x2cm prototype board and cut it down to 23 columns. Due to space limitations, I could only connect 6 rows on the ESP32 module, and leaving the last 2 unconnected. I also need to replace the standard resistor with the hand soldering SMD resistors to fit in the smaller board. I used a metal strip from the JST connector pin to create a ground rail at the bottom of the board, between the optocoupler legs. This saves me a lot of time bridging the ground connection. I also need to add a 100 microfarad capacitor right next to the JST connector. This helps the ESP module boot up properly when it's powered through the 5 volts pin. Next, we need to connect the wires to the dryer control board. To get access to the control board, unscrew the 4 screws at the bottom of the dryer to remove the roller base to get access to the control board. The control board is attached to the dryer case with plastic push pins. Use a flathead screwdriver to carefully pop these out. Then disconnect all the board's connectors. If you find a glue securing any of them, you may also need to remove the heater to make it easier to pull the PCB out of the case. This way, you can freely use a sharp knife to slice the glue out. Please note that the display screen on the front panel is attached to a clear adhesive sticker on the front. Once removed, it will be very difficult to reattach neatly without creating air bubbles. After removing the PCB, attach the 4 pins JST-XH connector to the provided I2C pin on the board. I prefer to mount it in the same orientation as the other connectors on the board for consistency. Next, I'll connect 24 AWG wires to each touch spring button. Try using different colors for each connection. This will help prevent confusion and make troubleshooting easier in later steps. To track when the power button is physically pressed, I connected another wire to pin 4 on the touch key IC, which is the power button output. This wire will go to ESP32 pin 10, which I'll set up as a GPIO binary sensor in ESPHome. To keep the wiring simple, I decided not to detect the other 2 buttons, since I can power cycle the dryer to get the accurate setting. I'll go into more detail about it later in this video. After reinforcing all the connections with hot glue, I bundled the wires together with a zip tie to keep everything neat and secure. However, after I bundled all the wires, I just found an unexpected issue. The wires themselves could sense capacitive changes from the signal wire connected to the touch IC, which could unintentionally trigger a button. To fix this, I need to redo the wiring, to add a resistor to each button. Through trial and error, I found that 100K resistors worked best. They effectively block unwanted signals, but still allow the optocoupler to activate the button as intended. However, if you're using ESP32 touch pins for detection, keep in mind that this resistor also blocks the signal to the GPIO pin. In that case, you may need to lower the resistor value, or connect the wire without resistor to detect the touch properly. Now, I will crimp all the wires with JST-XH connectors to connect them to the PCB. When inserting them into the housing, making sure to match each wire to the corresponding output from the PCB, just as shown in the wiring diagram. For anyone interested, I've written a detailed guide on hacking capacitive spring buttons that can be used on other devices too. You'll find the link to that guide in the video description. Since I needed to rewire the 12 volts input anyway, I thought it'd be a great opportunity to add a switch. It's a feature that wasn't included from the factory. Adding one here just makes it more convenient, especially when I need to reset the ESP module. I'll use a KCD1 rocker switch, and placing it right next to the 12 volts input. The recommended cut size for the switch is 19.2 by 13 millimeters. I marked the spot carefully, aiming to avoid any of the internal plastic ribs. Once I had the perfect location, I drilled a hole on each corner and used a mini grinder to cut slightly inside the outline. And I will finish it off with a metal file for a precise fit. Unfortunately, the case ended up being thicker than I expected. The cutting disc I had was too large to make a clean cut. So, I went with an old school approach. I drilled more holes along the outline, and using a hobby saw to cut it out. I finished it to the final size with a coarse metal file. It finally worked out well in the end. Next, I will rewire the DC input. I'll start by removing the DC jack connector from the back of the dryer. I'll take off the old wires from the connector and solder on new ones. I've used slightly thicker 18AWG wires. Once these new wires are in place, I'll cover each connection with heat shrink tubing for extra protection. The positive input wire will go through the switch. To connect to the switch, I will crimp it with a 4.8mm spade connector. Put the rubber protection back on. Then reassemble it to the dryer with the washer and nut. Once that's in place, you can connect it to the switch. I'm using this tiny buck converter and connect both input and output with 22AWG wires. This buck converter is used for step-down 12 volts input from the power supply to 5 volts for powering the ESP module. It fits perfectly in the wire slot on the side of the dryer. According to the datasheet, the ESP32C3 Mini supports an external power supply voltage between 3.3 volts and 6 volts. For this setup, I found it runs more stably when I set the output voltage to around 5.8 volts. To connect everything to the input from the power supply, I crimp the positive wires from both the control board and the buck converter with a spade connector to hook up to the switch. For the negative input, I connected it to the wire connector terminal. To protect the converter, I wrapped it up with a heat shrink tube. To connect the I2C from the Sovol control board, I also use JST-XH connectors. I only use SDA and SCL pins on the 4 pins connector to connect to the custom PCB. Now, you can place the motherboard back into the dryer and secure it with plastic push pins. You might also consider replacing the fan if it's getting noisy. The dryer uses a standard 12 volts 4010 fan to keep the air circulating inside, so it's an easy drop-in replacement. I swapped mine out for a 6000 RPM fan that has the same 0.08 rating as the stock one. However, this new fan has dual ball bearings, so it runs smoother and should last longer. Just make sure you install it with the label side of the fan facing toward the filament roller, so the airflow pushes directly to the filament. I also replaced the rubber cap at the filament outlet with an M6 coupler. This is a great upgrade if you're feeding filament directly from the dryer to your printer. The coupler keeps the PTFE tube securely in place while still being easy to detach. You can reuse the nut that originally secured the rubber cap to attach the coupler. To keep the dryer airtight, you can use a short piece of PTFE tube glued to a 3D printed cap. This can plug to the coupler when you're not using it, helping to maintain proper storage conditions for your filament. Now you can reconnect all the connectors back to the control board. Then attaching the signal wire, the I2C wires, and the DC input from the buck converter to the custom PCB. If possible, I recommend separating the wire to the 4-pin connectors from the I2C and power input wires. This could help reduce interference. Finally, tidy up the wiring as needed. Make sure each wire is securely placed in its slot, and doesn't block any screw holes. Once everything is in place, you can go ahead and reinstall the roller base. For the ESPHome firmware, you can start with essential components to test its functionality. After everything works as expected, you can easily add extra features later via OTA. I've used the default board configuration for ESP32C3. To read the Sovol internal environment data, you'll need an I2C section for the onboard AHT20 sensor. Then add the AHT10 sensor component, setting the variant to AHT20 for accurate readings. To simulate button press, I'll use the button component linked to the GPIO output that controls each optocoupler. Set the button duration to 0.2 seconds. For detecting physical press from the touch IC, I'll use a GPIO binary sensor component. Apply an invert filter here to reverse the status in Home Assistant, since the pin default's output is high, and drops to low when it detects a touch. Once everything is set up, go ahead and flash the firmware to the module with ESPHome as you usually do. Please note that, within the same batch I purchased these modules, I've found that some modules may require holding the boot button when plugging in to connect properly, while others can connect without it. To effectively control the dryer with Home Assistant, I need to create some helpers, and use automations to track and store its status based on button pressed. First, I've created two input booleans to track dryer's power status and active status. This helper basically on or off state of each status. Then I use three input selects to manage the screen status, set temperature, and set time. Now let me give you a quick overview of how it all works. When the dryer is plugged in, it defaults to the off state, meaning none of the buttons will work except the power button. The first automation tracks the power button activity, whether it's a physical press or a press through Home Assistant. This is done using a GPIO binary sensor that detects signals from touch key IC. When the state changes, it toggles the power status input boolean. Once it's powered on, the dryer goes straight to the idle page, with default settings of 40 degrees and 6 hours. All this will start over when the dryer powers off. So, this automation also checks the power state. If it is turned off, it also runs a reset script that sets all helper values to their starting defaults. For the other two buttons, which physical presses aren't monitored, their automations only trigger when the buttons are pressed in Home Assistant. By pressing the M button, it will cycle through each screen option in the screen status input select. When in temperature or time mode, pressing the A button will adjust the respective setting. For example, if the screen is in temperature mode, by pressing A button, it'll go to the next available temperature option. Once the screen returns to info screen, the automation marks the dryer as active by turning the active helper to on. At this point, it starts the timer and any related actions. I've also exposed the active status to ESPHome and changed the setting button's platform from output to template. With the template button, I can add a condition to check the button state before executing any action. This ensures that the setting buttons are disabled while the dryer is actively drying, preventing accidental changes while it is active. However, you can still press the buttons on the dryer itself to adjust the settings, though these changes won't be reflected in Home Assistant. Since physical presses for the two setting buttons aren't tracked, there's a chance for settings to go out of sync. So it's a good idea to reset all settings by powering off the control board before starting any automated actions. You may also need some additional automations to keep the helpers in sync with the dryer status. For instance, one automation monitors the dryer's auto-off feature, which activates if the info screen is left on for 3 minutes. Another resets the screen back to info screen, if no buttons are pressed in temperature or time mode within 5 seconds. If you want the dryer to run with preset values, you can create a script to simulate button presses in a specific sequence. Be sure to include a short delay between each press, to ensure the buttons are triggered properly. In my case, a 400 milliseconds delay worked perfectly. For added functionality, I've created a few extra helpers. These include a finish time display, a runtime counter, and a custom timer. The custom timer is particularly handy, as it allows you to set drying times shorter than the dryer's default minimum of 6 hours. I've put everything in 2 YAML files. One for essential functions needed to control the dryer, and another optional file for extra features. So you can easily add them to the Home Assistant Packages folder. The files include all the helpers, automations, and scripts you'll need. Just make sure to update the entity names in the YAML file to match your setup. I've also included an example dashboard YAML that matches what you see in this video. You can find everything in the written instruction linked below in the video description. Overall, I'm pretty satisfied with this hack. It's so much more convenient to control and monitor the dryer wirelessly. Setting it up with drying presets or a custom timer is super easy. Plus, the added benefits of knowing the estimated finish time and runtime are really handy. However, there are still a couple of limitations. The setting buttons don't track physical presses, due to limited space inside the dryer. Initially, I thought resetting the settings by powering off the control board before starting fresh with automation was good enough. But over time, I realized having this feature would make things even better. I also ran into some E0 errors on the control board. While I haven't pinpointed the exact cause, it's been somewhat random. Although these errors aren't frequent, they can still be annoying. The dryer often works fine for days without any issues. But sometimes the error pops up after just a few hours of operation. When it happens, the dryer briefly displays a warning and emits a sound before resuming normal operation. However, in some cases, I've had to power cycle the control board to clear the warning. I use the dryer with an 𝗬𝗢𝗢𝗪 strip that I flashed with ESPHome Firmware in a previous video. So I can create a script and add the button to the dashboard for easy power cycling. If you're curious how to did it, you can check it out in the previous video linked above. I'm working on an external mounting for a larger ESP32S module. With its touch pin, I'll be able to detect physical touches for additional buttons. Placing the module externally keeps it away from the dryer's heat, which could improve stability and reduce temperature-related issues. I hope this video gives you a clear idea of how to integrate a simple device with capacitive spring buttons into Home Assistant, or at least inspires you with some ideas for your own projects. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe for more DIY ideas and projects. Have questions or suggestions? Drop them in the comments below. I'd love to hear from you. Thanks for watching, and I'll see you in the next video.